Alright, what's up everybody? So with this video we're getting into special right triangles. And so the way that these ones work is there's a certain pattern or a certain relationship that the sides have in these triangles. And we're only going to be looking at two. And as long as you know how the sides relate to each other, it's fairly straightforward. However, the most complicated part of this is going to be dealing with the radicals, whether you're dividing by radicals or multiplying by radicals. You do have to kind of do the math correctly, because most of the time I'm going to ask for your answers when it comes to this in a simplified radical form. So just be aware of that, okay? So without further ado, let's kind of jump into this. So our special right triangles come in two different categories. You have your 45, 45, 90 and your 30, 60, 90. And what those numbers are referring to are the interior angles of your right triangle, right? So they would look kind of like this. So notice on the left we have a triangle that has one right angle that's 90 and the other two angles are 45. On the right we have the 30, 60, 90 where we have our 30 degree angle, our 60 degree angle, and our 90 degree angle, okay? Now we're going to start with the 45, 45, 90. Now the 45, 45, 90, hopefully it jumps out to you that both of those other angles are the same, right? And so that would then mean that these two side lengths are congruent. So a 45, 45, 90 is an isosceles right triangle. It has two congruent legs, and then it has its hypotenuse. Now, with both of these, it's all going to be determined on what side you're given, because there is a constant relationship between the legs and the hypotenuse for both of these triangles. They're different relationships, but both are going to have relationships. So for the 45, 45, 90, we know both legs are going to be the same. So we're going to put that in terms of x. So I know this leg is going to be x, and this leg is going to be x. And again, that's just showing that those two legs are the exact same size and length. Now, if we were to do Pythagorean theorem here, like x squared plus x squared equals unknown squared, all right? Now, we're not going to go through that whole process. Just know that if you have an isosceles right triangle, a 45, 45, 90, the hypotenuse length is whatever the leg length is times radical 2, okay? So this is a constant relationship. So if my leg was 5, my hypotenuse would be 5 rad 2, okay? And so where these become difficult is depending on what length you are given, whether it's this one or this one, and then also what the actual length is. If it's a whole number for a leg, it's easy. If it's a decimal or a fraction or a radical, it becomes a little bit more difficult. And it's mainly just more difficult algebraically, not set up wise, because they're all going to set up the same. So let's look at a very straightforward problem, like the one I just said. So I know this is a 45, 45, 90, as in it was given to us. So I know then that this missing leg is also 5. And then I know that my hypotenuse is 5 rad 2. It's whatever the length of my leg is times radical 2. And again, I'm going to be asking that you leave your answers in simplified radicals for pretty much all these special right triangles. Let's look at a different scenario. So notice in this case, they're giving us the hypotenuse. So the hypotenuse is 6 rad 2. So let's go back to our original diagram here. So if I'm given the leg, I multiply by radical 2 to get my hypotenuse. If I'm given the hypotenuse, I divide by radical 2 to get my leg. So in this case, I would take 6 rad 2, divide it by radical 2. The radical 2's cancel each other out, so my leg lengths are 6 and 6. Right? So notice if I multiplied this by radical 2, I get 6 rad 2, and it follows the same concept that I did in this problem right here. Let's look at another one. So now my leg length is 2 rad 2. So I know that this is 2 rad 2. So then I need to take my leg length, and I need to multiply that by radical 2. Remember, when we're multiplying radicals and whole numbers, we can only multiply and combine things that are alike. So the radical 2's get multiplied together. So rad 2 times rad 2 is rad 4. 2 times square root of 4 is 2. 2 times 2, which would be 4. So our hypotenuse length is 4. So again, rad 2 times rad 2 is 2. 2 times 2 gets us 4. All right. Let's look at another one. So now notice that we have our 10 as a hypotenuse. And remember, if we are given the hypotenuse, we divide it by radical 2 to get our leg. So I'm going to do 10 divided by radical 2. Same thing's true when reducing. Because the 2 is underneath the radical sign, I can't reduce it with the 10. And if you remember back to when we were simplifying radicals, we cannot leave a radical in the denominator. So we multiply by whatever's in the denominator to both the numerator and the denominator. So 10 over rad 2 times rad 2 over rad 2. That gets us 10 rad 2 over rad 2 times rad 2 is 2. Now that the 2 is out of the radical, we can reduce it with the 10. 2 goes into 10 5 times. This 2 is out of the radical, so it cannot interact with that 2 there. So the radical 2 stays in. So both of our legs are 5 rad 2. Okay. So as you can see, the setup for these is very straightforward. It's the algebra that you have to kind of expand on. So now let's look at a 30, 60, 90. Okay? So with our 30, 60, 90, it's the similar type of idea where you're going to have relationships all based off an x. So I'll tell you right now that the 60 leg is always the one you hope you want to get, because that's how the other two, you find the other two based off the 60 leg. Now, if you're not given the 60 leg, then that's going to be the first one you want to find based off what you're given. Because here's the relationship. If your 60-degree leg is x, the hypotenuse is 2x. It's double the length. The 30-degree leg is whatever the 60-degree leg is times rad 3. And here's kind of how I remember that. 33, so as a 30 it has a 3. Rad 3 has a 3. So I know the 30 leg is always the one that has the x rad 3 attached to it. Okay? So again, you have your 45, 45, 90, which is x rad 2. You have your 30, 60, 90, which is the 60 leg is x, the 30 leg is x rad 3, and the 60, or the hypotenuse, is double the 60 leg, or 2x. And I'll show you what I mean by if you're not given the 60 leg first, that's the one you want to find. So let's look at this problem right here. Okay, so I have 30, 60, 40. So my 60 leg is 4. That means my hypotenuse is double that amount. So my hypotenuse would be 8. My 30 leg is whatever my 60 leg is times radical 3. So 4 rad 3. All right. Let's change up what we're given. So now they're giving us the hypotenuse. So one more time, just so we have it for reference. 60, 30, x, 2x, x rad 3. So now notice they give us the hypotenuse. Well, the hypotenuse we know is double the length of the 60 leg. So I'm going to divide my hypotenuse by 2 to get my 60 leg. Once I have my 60 leg, I'm going to multiply that by radical 3 to get my 30 leg. Do another one. So now they gave us our 30 leg. Very similar to now giving us the hypotenuse in the 45, 45, 90. We know that to get from x rad 3 to x, okay, think about this. How would I make this equation equal to this equation? I would have to divide by radical 3. Okay? So, in order to do that, I take my 30 leg and I divide by rad 3. Remember, the 9 and 3 cannot interact because one's under a radical, one's not. So we multiply by rad 3 over rad 3. That gets us 9 rad 3 over 3. Now, because the 3 has come out of the radical in the denominator, I can reduce it. So that means that this is 3 rad 3. Once I have my 60 leg, I double that amount to get my hypotenuse. So 3 rad 3 times 2. This 2 can only interact with the 3 that's out in front. So that gets me 6 rad 3. That is my hypotenuse length. Okay? So guys, there's 3 variations of this one. You can either be given the 60 leg, the 30 leg, or the hypotenuse, right? And so if I'm given my 60 leg, I just multiply by 2 to get my hypotenuse. I multiply by rad 3 to get my 30 leg. If I'm given my hypotenuse, I divide by 2 to get my 60 leg. I multiply this by radical 3 to get my 30 leg. And if I'm given my 30 leg, let's just call it 12, I would divide by radical 3 to get my 60 leg, and then whatever I get there, I multiply by 2 to get my hypotenuse. I'm here to help you. Today's going to be good practice. Remember, we're going to revisit this again on Thursday. Let me know if you have any questions.